All right, yesterday we talked about the topic of inverses. And the key to doing an inverse, you're given some log or exponential type equation. And to find the inverse, you're going to take any x and any y, and you're going to swap them. That's going to be the start of your problem. I always like to do this like in the other order, but it doesn't really matter. So if I'm going to rewrite this, we'll just go ahead and write it as it is. But this is now a y, and now it's equal to x. So that's got to be step one every time you're doing your inverses. Get it rewritten where the x and y are swapped, because that now inverts the equation. It swaps the x and the y. From here, your goal is to isolate this y. To do that, the first thing we need is we need this log by itself. So there's this 2 out here that's being multiplied, just like any other solving you've ever done. Let's get that out of there. So if we divide by 2, now we have log base 4 of y equals x over 2. And this log is now isolated. We can now rewrite our log as an exponential, because that's really what we know is going to happen. If you start with a log, the inverse is going to be an exponential. And if you start with an exponential, the inverse is going to be a log. So now I can use my rule here and convert this to, okay, so my base is 4, my power is x over 2, and it's equal to the argument, which is y. And actually at that point, I'm done, right? Because the y is solved for. Y is simply equal to 4 to the x over 2. And these are going to usually look weird, which is totally fine. Like, expect kind of a weird equation for your inverse. Expect, you're going to have fractions, you're going to have things added, subtracted, whatever, because you're really just undoing all the steps that are over here. All right. This one, instead of having a y, it has the function notation. But again, this is the same thing as a y. So step one is swap the x and the y. So I'm going to write x equals log base 3 of y plus 1. Now in this problem, our number is trapped in the log, like this plus 1. Whereas here it was outside of it. So that's why we moved the 2 right away. In this problem, though, we can't do that because it's in the log. So this one, we're going to go right to rewriting it as an exponential. So I'm going to say 3 to the x equals our y plus 1, the argument. And now we're almost done. To get the y by itself, we would just have to subtract the 1. All right, so now the y is by itself. We usually like to write it with the y in front. You don't have to, but generally do. So now you have 3 to the x, and then from that, you're subtracting a 1. And there we go. And so same thing here. Sometimes I would rewrite this one where I might write it where it's in this format, just because like the y equals format is sort of the normal way to write these. Obviously, they're both equivalent. It doesn't matter the order. But traditionally, you see them written like that. And there we go. So hopefully that helps out with the inverse problems.